All right, then the last page was using a protractor. This is without using a protractor. So it says work out the angle sizes and state the reason or reasons for each one. Well, the first thing I notice is these two are vertically opposite. And this one here is an angle, looks like an angle on a straight line. So straight line here, so I've got A is going to equal 180 minus the 53. And that would give us this point here. Let's try that. So I've got 180. Let's take off the 53. And we get 127. Equals 127 degrees. So there it is, 127 degrees. And I put some angles on line equal 180 degrees. Now, of course, you could put probably a better reason, really, it would be angles or angle angle pairs. I should put angle pairs. I like that better. Angle pairs on line are supplementary. Yeah. Now B, well, these are vertically opposite angles. So B is just 53. And I'm going to put vert op angles equal. That's fine. All right, C. Well, here we've got a triangle. We've got this angle on the outside of the triangle. Well, we know that this angle here on the inside of the triangle, this must be a straight line. So if I took 180 and I subtracted the 65, I would get, let's have a look, 180 minus 65. Oh, that was 190. Gosh, look at that, 180 minus 65. Not a good day. Is 115 degrees. It's equal to 115 degrees. So that's a degree sign, by the way. Looks more like a 1,150. It's 1,150 degrees. There it is. I'm not doing well here today. So this is this bit here is going to be 115. So now we've got 39 and 115 and C. Now the way we do that is we'd simply add those two together. So we've got 180, and I'm going to take off the 115, and I'm going to take off the 39. Now, another way, of course, of doing this, by the way, is to take the external angles equal to the sum of the two interior opposite angles, but you probably haven't done that. So we're just going to take this angle here, which is going to be angles on a straight line. So we've got this one here, which we've worked out is going to be 115, and we're going to take the 180 of the triangle now. I'm going to subtract that one, subtract the 115, because that's 115 now, yeah, degrees, and see what we end up with. So here we are, we've got 180. We're going to take off the 39 and the 115, there it is, and we've got 26. So this angle here, C, is going to be 26 degrees, and we're going to say, sum of internal angles of triangle equal 180 degrees. I think that'd be quite a reasonable thing to do, really. Yeah. Or if you really want, you could say the external angle is equal to the sum of the two interior opposites. But again, you may not have done that, so I don't think we need to worry about it. All right, this one just looks complicated. It's really not that complicated. But we've got some nice things here, which are nice and easy to do. First of all, we've got an equilateral triangle. And an equilateral triangle, well, this is nice and simple, because we know that each of the internal angles of an equilateral triangle is 60 degrees. So this is 60 and 60. I won't put the degree sign there, we can't really fit it in. 60, 60, 60. So there they are. And D, therefore, this is angles on a straight line. So D, that's going to be 180 minus 60, and that's going to be 120. Let's just check that. So we've got 180, here we go, 180. We're taking off this, taking off that 60, and we get 120. So D is 120 degrees. There it is. Reasons, gosh. Yeah, there's two reasons. So the first reason is we've got angle in equilateral triangle equals 60 degrees each, I'll put. Yeah, and then the second reason is angles on line equal 180 degrees. In fact, we probably should put sum of angles on line equal 180. So E, therefore, well, now we've got, these are angles in a quadrilateral. We've got 120, we've got 97. This is a 90. So if I took 360, because they all add up to 360, if I took off the 120, I took off the 97, and I took off the 90, there they are. What do I end up with? And that would be E. So I've got my 360. I'm taking off my 120, my 97, and my 90. What do we end up with? We get 53. So we've got 53. So this is 53 degrees. So E is 53 degrees. I'm going to put some internal angles of quad equal 360 degrees. And that's what we've got. Now again, these just look nasty. They're really not though, yeah? Well, the first thing to notice is this is going to be an isosceles triangle. So this angle here must be the same as this one here, which is 72 degrees. So there it is, yeah? So that one's 72 degrees. And therefore F is going to be 180 minus 2 lots of 72. So let's see. So the first one is this one here. So I'm going to take 180 and I'm going to take off the two angles here, which is minus 72, or you could say minus 2 lots of 72. So let's do that now. So we've got 180 minus 72 minus 72, and you've got 46 degrees. So F must be 46 degrees. Now the reasons are base angles isos triangle are equal. And the second reason is the sum of the internal angles of triangle equals 180 degrees. Now G, I like G. Now we know some things here. We know this one here. We know F, yeah. F is 46. So I'll just put a little 46 there, 46. So we know that this is 117 and 46, and the rest of this, all of that must come to 360. So we've got 360, and we can take off the 117, we can take off the 46, and we're left with whatever G is, because we've got angles at a point. So we've got 360, we're going to take off the 117 and the 46, and we're left with 197. So 197 degrees, and the reason is the sum of angles at point equal 360 degrees. And there we are. Now the final one here, this is a bearing. I like bearings. Bearings are very cool, really. Let's have a look at this one. So we've got bearings. And it says, based on the diagram below, complete the following statements. So a boat needs to travel on a bearing of something from A to B. Going from A to B. Well, this is rather odd. Well, this is 78 degrees, but of course, if that was written as a bearing, which it is, it's going to be 078 degrees. It's a trick question, really. This is an angle, but if you write it as a bearing from north, it has to be 078 degrees. So they've written it as an angle, hasn't it, going that way, you see. And a bit naughty. Really, in fact, really, they should actually write the angle as with a little arrow that going that away, yeah? But we're going to use the bearing of 078 because it's always from north. If it travels on a bearing of something from B back to A, so if we're going from B again, we must go from north each time. Okay, well, these are angles at a point. So if we take the 360, we subtract the 102, we'll get this angle here. So let's do that now. We've got 360. We're taking off 102, there it is, and we get 258. So this must be 258 degrees, and the bearing is 258 degrees. And that's how we'd solve that.